Good afternoon, class. So today we'll be discussing work and energy. Now, energy is one of the most important concepts in science. Energy can be in any form. It could actually be mechanical energy, chemical energy, electromagnetic energy, sound energy, heat energy. But according to the universe, the amount of energy never changes. It can be just transformed to one form to another. Now, energy by definition is actually amount of work one system can do to on another. So, kung may energy ka, actually makakagawa ka ng work. So, energy is actually defined as change in work or the amount of work. So what is work pala? So work is mechanical work is concerned with the application of force of an object and the distance the object moves as a result of that force. Now, in short, work is done if an object moves through some displacement while a force is applied on it. What do you mean by that? Kung nag-force ka, may force ka na in-apply, tapos yung isda na to, from the ground, nag-move siya at a certain distance, displacement. Ibig sabihin, nag-work ka dito. Kung itong sasakyan na to, meron siyang certain force, nag-move siya at a certain distance, meron din siyang work. At si gravity, yung bato na to, nag-move siya at a certain distance, sabihin natin dito sa side na to, distance or displacement. At of course, meron tayong tinatawag ng gravitational force there. Therefore, si gravity may ginawang work. Okay? So, tingnan natin yung difference ng dalawang to. Ito, ikaw yung gumawa ng work. Ito, si gravity yung gumawa ng work. So, work is, by definition, is actually force times change in x, or we say displacement. What is displacement? That is your x final minus your x initial. Ganun lang siya. But actually, there is what we call positive and negative work. A positive work is whether you're accepting or you're giving out work. So, for example, a baseball pitcher, for example, does a positive work on the ball. So, since siya yung magpupush nung ball, ibig sabihin, siya yung gumagawa ng work. Siya yung gumagawa ng work. So, that is a positive work. But what if ikaw yung catcher? So, andito si catcher. So, meron siyang gloves. Tapos, siya yung tatanggap ng ball. So, may ball. Papunta naman yung ball sa kanya. Yan. Now, siya yung receiver ng work. Therefore, sa kanya, negative work. Since the catcher will receive the work. So, it has a negative work. So, sometimes we have a positive and negative work. So, depende kasi siya kung ikaw yung gumagawa ng work or ikaw yung nag-a-accept ng work. So, let's go back to the definition of work. Work is if there is force applied and you move it in a certain distance. That's why the formula of work is this one. So, but may mga cases na ang ina-apply mong force ay patagilid. Hindi siya yung straight, like for example, ganyan. Pinush mo yung box papunta dyan. So, nag-move yung box papunta din naman dito. So, they are actually, nag-move yung box papunta dito. So, sila ay parallel. Parallel. Ibig sabihin, ang force mo pa ganon, yung movement mo din pa ganon. yung movement ng displacement mo pag ganon. Same rules with, kung may box ka, binuhat mo pataas, yan, let's pretend na nagbubuhat ka ng box, yan. Ang distance mo, ang force mo is, yung force mo pataas, at yung box mo din, yung distance ng box mo din, or yung displacement ng box mo ay pataas. So, pag ganyan lang po, the formula that we actually use is work, force, times distance, or force times displacement. Kung gaano kalayo, or force times the change in x, or change in y. Depende kung paakyat or patagilid. But what if may angle ng kasama? So, let's use a different color here. What if may angle ng kasama? If may angle ng kasama, we now add, not really add, we multiply cosine theta. Now, cosine theta actually represents the angle between the distance, the force, and the displacement. So, we use this formula. Now, ma'am, bakit ito hindi na natin ginagamitan ng cosine? It's actually same. Di ba, pag papunta sila doon, ang distance lang ng dalawang yan, ni force at ni displacement, ang angle lang nila is 0 degrees kasi magkaparallel lang naman sila. So, the cosine of 0 is just 1. So, parang wala lang din. So, you just use this formula in case there is an angle involved in the problem. So, for this one. Now, tingnan natin Kunwari guys, binuhat mo yung bucket na to. Tapos, dinala mo yung object papunta doon. So, dinala mo yung object papunta doon. So, this is the change, the distance. This is 90 degrees, right? If we solve this, work, force times distance or displacement cosine 90, you will actually observe that cosine 90 is 0. So, ibig sabihin, work mo ay magzi-zero out na to kasi any number multiplied to 0 is 0. So, therefore, pala, in this diagram, no work. No work done by the person and no work done by gravity. Kasi si gravity papunta sa baba, pero ang bucket mo papunta doon, same rules. 90 degrees pa rin siya. So, meron na tayong limitation when it comes to energy, to work, the definition of work. Kasi, dapat sila ay hindi 90 degrees. Kasi pag 90 degrees, magzi-zero na yon. Or, let's say, hindi sila perpendicular. The force should not be perpendicular to the displacement. Kasi magzi-zero ang ating work. But how about this scenario? Kunwari, pinul niya yung box pataas. So, meron siyang applied force. Tapos, yung box from here, umakyat naman siya. So, pansin nyo, same direction lang siya. So, we can actually just use the formula of force times change in x. Change in x, kasi ito yung distance, right? Now, that means you have a positive force. Pero what if kung binaba niya yung box? Ni-lower niya yung box. Binaba naman niya. Pag ganon, the work will be negative. Bakit po negative? Kasi negative distance. If this is 0, this will be a negative, sabihin natin, negative 5 meters. Kung wala lang negative 5. Kasi di ba nasa baba, nasa 0. Ito ay positive 5. So, they will have a negative. But sometimes, if you consider this as your 0, wala namang problema yan. So, this will be a negative work and a positive work. And that also includes the receiving and the receiver and the, kasi depende yun sa force, direction naman ng force, yung sa receiver at sa catcher. Tama ba? The giver of the ball yung example natin kanina, the pitcher and the catcher. So, iba naman yun, kasi direction na siya ng force. Now, let's have an example here. A car pushes a car pushes a car is pushed horizontally with a constant force. So, mayroong sasakyan dito. Let's just pretend na may sasakyan. Yan. Guys, papayaan nyo na sasakyan yan. Yan, sasakyan. It is pushed, so pinush siya, horizontally with 210 newtons. So, this will be my force. And it actually moved with a 9-meter track. Yan. That will be my displacement. How much work is done? And that is simply force times distance, which is 210 times 19, and the answer is this one, 3,990 joules, and that is our work. Let's have another one. A 1 kilogram ball is thrown upward, reaching a distance. So we have now a distance. Tinapo natin yung bola. We have now a distance of 4.5 meters above the point. So this will be our displacement or our distance. What is the work done by gravity on the ball? Ayan. Work done by gravity. So si gravity. Ayan si gravity. If you remember, gravitational force is also known as the weight. Sana maalala nyo. And the formula of weight is mass times gravity. Now, so therefore, ito na siya. If work is force times distance, but force, gravitational force, or weight is mg. Now, ito siya. Okay? So we can now just plug in what we know. So we have here the mass, 1 kilogram, 9.8 for our gravitational acceleration, and our distance 4.5. And we will have an answer of a 44.1 joules. Now, please remember that this is negative. Why? Kasi si force, pababa po si force natin. Kasi nga, gravity siya. So, negative to. That's why the answer here is negative. So, what is negative pala at positive? Hindi naman siya ibig sabihin mas malakas, mas mahina. It's more of direction. Pag sinabi mo kasing negative, pababa yung direction ng force or ng displacement. So, depende siya. So, again. Okay. Now, let's use another example. But this time, let's use the formula of W F D cosine theta. Okay. So, a force of 50 newtons is exerted on a box at an angle of 45 degrees. How much work is done by the force of the box along the table with a distance of 2.75. So, all you have to do is actually, ito na yung force mo, ito yung theta mo, at ito na yung distance mo. So, let's just plug it in. 15 newtons, cosine 45 degrees, nakalimutan ko si D. Wait lang guys, ilagay ko natin si D dito. Si D ay 2.75 meters. And actually, you will get an answer of 29.2 joules. And that is how simple we compute for work. But what if we have multiple work? So, pag sinabi mo kasi multiple work, ano siya? Di ba hindi ka naman forever. So, sabihin natin, nag-push ka ng box. While you have here a box, you push this box. Pinush mo yung box na to. Pinush mo siya ng 10 newtons. Sabihin natin 10 newtons. Pero habang tumatagal, pwedeng nanghihina ka. Sabihin, ang push mo na lang ay 5 newtons. Nanghihina na yung force mo. So, later siguro, mas mas nagiging iba na rin yung distance mo. Kung dito na-push mo pa siya ng 5 meters, ito 2 meters na lang. So what if we have a work that has different instances? So all you have to do is compute for the force times distance of the first scenario, ito, and then compute for the force times distance of the first, yung isa, and the second scenario naman yung isa, and so on and so forth. And we will have what we call the total work. But what if you have a lot of forces giving the same direction? For example, ito ikaw to, tapos ito naman yung ate mo, yan, ito naman yung aso nyo, sabihin natin yung aso nyo, ayan. Kayo tatlo, nag-apply kayo ng force. You have different forces, but you have different strength kasi iba-iba kayo na tao. So, pinush nyo yung box to have a certain distance of 10 meters. Now, what is your total work? All you have to do is add all your forces here and multiply it to the distance that you have reached when you push that box. So, ito yung mga formulas natin for multiple forces or multiple scenarios ng force distance to arrive sa work. Okay. So, example number 4. A 120 kilogram crate is placed on a flat bed of a truck. The truck is moving with an acceleration of 1.5 meters per second squared along the positive x-axis. What is the total work done on the crate by all forces acting on the truck that carries it to a distance of 67 meters? Assume that the crate does not slip with respect to the truck during motion. Okay. First, tatandaan nyo muna, ano ba to? This is mass. Ano to? This is acceleration. Ano naman to? This is your distance. Okay. Now, naalala nyo ba? Sinabi kasi ito all forces, but let's make a shortcut. I-shortcut muna natin. The force applied in this object is mass times acceleration. I hope you still remember the second law of motion. Ano talaga ang formula ng force? The general formula of force, mass times acceleration. We already have a mass here. We already have an acceleration. And we have a distance. I think we can compute for the work. Now, the work here is force times displacement or the distance, where force is just the mass and the acceleration times 60 times the displacement. Or simply, if I will write this 120 times 1.5 meters per second squared times 67, I will have the answer. Pero ang problem kasi dito sa ito, sinasami niya yung word na all. So, it actually wants us to evaluate all. Ito, all. So, let's go to the illustration. Now, we know that the distance between this initial to the final distance is 67 meters. That's the displacement. And we have acceleration of 1.5 and a mass of 120. Now, what is the total work? But before that, to get the total work, let's talk about the total forces acting on the box. So, we have what we call the normal force, the gravitational force or the weight, and the friction. So, itong dalawang to, hindi naman nag-move ang box pataas at sa baba. So, this is actually equal to 0. So, we don't really need to compute for this one kasi nag-0 lang naman yan. Now, solving for this one, F, along the x-axis, we only have this force. Yan. Static friction. Papunta siya doon, since nag-move siya with an acceleration, the summation along x-axis is equal to ma. But the force that is only present there is friction, which is equal to MA. Now let's compute for MA. Compute for MA, we have this one, and then 180. Now, if you total it with work, ito ay 0, ito ay 0, ito ay 180 times 67, we actually get this answer, 12,060, which is the same with this one. Ayan. Okay. Okay. Now, let's relate mechanical work. So, how do you compare the two tasks in terms of mechanical work? Now, walking up the stairs and running up the stairs. Now, ito, ang walking up, easy, less energy ata, easy, pero slow ka. Ang running up, siguro mas harder kasi mas kailangan mo ng body energy then, pero siya ay faster. Now, ang tanong ko sa inyo, sino mas powerful? Yung umakyat na nag-walk or yung nag-run? Now, what is the definition of power when it comes to physics? Power is actually the rate at which the force does work. Now, what do you mean by that? Ang sinasabi lang niya ay power kung gaano kabilis nagawa mo yung work. Again, it is the rate of work. So, gaano mo kabilis nagawa yung work. Or, pwede din, the velocity and the force. What is the velocity of the force? Ito naman, how many per second mo nagawa yung work. Or the velocity of the force. So, these are the two formulas of power. Rate at which the force does work. So, the units for this is watt. And W. Watt. So, let's have an example. A small motor is used to operate a lift that raises a load bricks weighing 1,200 newtons at a height of, in 30 seconds. Now, let's compute for work. This is force. Obviously, this is force because, and this is displacement kasi meters. But this is time. Okay. Now, power generated, power is work over time. So that would be 1,200 divided by work is, if I remember, work is force times distance. So I have to multiply this by 15 and then I divide it by 30. And the answer there is 600 watts. Okay, remember, work is force times distance. If you divide it by time, it's called power. Now, a motor is lifting naman, example number 6, lifting a 200 kilogram object at a constant speed of 3 centimeters per second. What power in horsepower is being developed by the motor? Now, please remember that we have to go back here. In the US, ang ginagamit natin actually dito ay horsepower, hindi watts. So, ang pwede mong gawin ay, you just have to remember the following units. 1 horsepower is this one. 1 horsepower is 746 watts. Okay, let's remember that. 1 horsepower is 700. Nakalimutan ko na agad. 46 46 watts. Ayan. Yan yung conversion natin, ha? Okay, let's try. This is already in kilograms. That's fine. This one, I think we have to convert this. Please remember that hindi tayo gumagamit talaga ng centimeter. So, let's use -2 meters per second tayo. Yun yung ginagamit talaga natin. Now, please remember the two formulas of power. Work divided by time, but there's another one, force times velocity. And I intend to use that. Okay? Now, since this is lifting, I will use mg, gravitational force, kasi nagbubuhat siya. Okay? So, let's just try that. This is mg, the force is mg, and multiply to the velocity. So, we have here 200 times 9.8 times 3 times 10 to the -2. Ayan. But we have to have a conversion. I will use another color here. Okay. The answer for this one is watt. Naka-watt to. So, to convert that, let's convert. We have to multiply it with 1 horsepower is equal to 746 watt. So, magka-cancel lang to. And if you answer that, you will have this one, 0.08 horsepower. Remember, ito conversion lang to, ha? Itong andito. Kasi ang ilalabas na sagot dito is watt. Naka-watt siya. Pero ang hinahanap kasi sa problem ay naka-horsepower. Kaya natin naglagay tayo ng conversion. Okay? And that's the answer. Now, let's focus now on energy. So, energy is the ability to do work. So, it has two main components, what we call the kinetic and the potential energy. So, the kinetic energy is an energy associated with moving. Anything that is moving, a particle that is moving, a car that is moving, it has a kinetic energy. A kinetic energy, that's why it's related to moving, kasi na-achieve siya by having the value of the speed, the mass times the velocity of the object squared. So, yan. If you increase your velocity, the higher is the kinetic energy. Okay. Please remember na kunwari may mga atoms, tapos excited sila, nagmo-move sila with a high velocity. Di ba ang mangyayari sa sobrang movement ng mga atoms na yan, magkakaroon ng higher energy. At yung kinetic energy na yan ay nako-convert into heat energy. So, in short, tumataas ang kinetic energy pag tumataas yung velocity. So, let's just check kung gaano kataas. Kung ito-double ko yung speed, so let's double. Ito-double ko si speed. Mass 1/2. Anong mangyayari kay kinetic energy? Square nito. Ang kinetic energy mo ay magiging 4 times greater than the normal one. So, ang normal na sinasabi ko ay hindi double to. So, square nito, kaya siya 4. What if kung ginawa ko tong like 3? Yung velocity, 3 times yung velocity. Wala natin. Ang mangyayari ay, what is square ng 3? Ang kinetic energy natin ay naging 9 times. 9 times stronger siya compared sa before. So, kinetic energy is an object that undergoes a displacement and change in velocity. Nagkakaroon po ng kinetic energy. Okay? Now, ayan. Now, this one, you can check this one, yung mga derivation dito, but the main point of this derivation is work the net energy work is actually the difference between ano man talaga nagawa mong trabaho. Ang nagawa mong trabaho ay yung kinetic energy mo nung initial at yung kinetic energy mo nung final. Pag minus ko yan, wait lang. Pag minus ko yan, nagkakaroon ako ng tinatawag na work. So, the change of kinetic energy is actually work. It's called the energy work theorem. So, ayan. The work done by the net force of a particle equals to the change of particle's kinetic energy. So, let's have this one. What is the kinetic energy of a 6 kilogram medicine ball traveling at 4.50 meters per second? Now, this is actually relatively easy. The formula is 1/2 mv squared. So, 1/2 6 kilograms. Just be sure na kilograms, meters, and seconds sila lahat. 4.50. Don't forget the square of this one. And if you answer that, you will have a kinetic energy of 60.75 joules. Okay, let's go to example number 8. With what speed would a 72 kilogram jogger have to run to have a kinetic energy of 1,200 kilogram car traveling at 2.0 kilometer per hour? Okay. So, ayan. Ang tanong niya ay ganito. May jogger. May car. Okay. Si car, meron siyang kinetic energy, right? Ang kinetic energy niya is 1/2 mass ng car v squared ng car. Si jogger naman, meron siyang 1/2 mass, pero ito yung nawawala sa atin. Ano daw to? Okay. To get that, all we have to do is you can actually cancel the two. Itong dalawang to, magka-cancel na to kasi pareho lang naman sila. V squared is equal to MC VC squared divided by M jogger. Okay, mass ni jogger. If you square root this, you will have MC. Okay, you will have, wait lang, V is equal to M, mass of the car, velocity of the car, divided by the mass of the jogger. And that is the jogger velocity. Yan, pag na-square root mo na yan. Let's just check kung paano natin siya ginagawa. So, ayan. You can always use this formula or you can use this diagram. First, i-compute mo muna tong kay car, yung kinetic energy ni car. You can solve this. Dapat mag-equal lang siya sa kinetic energy ni jogger. So, ayan. Ito yung kinetic energy ni car. Now, okay magtaka. 1/2 V squared. Tama? Pero ang problema, we don't use kilometers. I hope you remember, ang ginagamit lang po natin sa velocity is meters per second. So, kailangan mo siya i-convert into meters. So, meron tayong meters dito. Yung hours, dapat naka-hours yan. So, dapat naka-seconds yan pala. So, kailangan mo siya i-convert. So, kaya, yan yung lalabas. Then, isu-square mo pa. And you will have this answer. Now, if you get this answer, ang tanong, ano dapat yung velocity ni jogger para ma-achieve yung ganitong kinetic energy? So, kinetic energy ni jogger ay dapat ito is equal to mass ni jogger V squared. Okay? Then, if you compute that, ayan. 1/2. Nakalimutan ko si 1/2. Ayan. 1/2 V squared. And if you compute that, you will have this answer. Kailangan mo po ito i-square root, guys, ha? Kailangan nyo i-square root yan. And you will have 2.3 meters per second. That is the velocity of the man or the chugger to have the same kinetic energy with the car. But you can always use the formula that we have kanina. Mass of the car. Okay, I'll use another color. You can use the mass of the car, mass of the chugger, and itong V squared, yun nga lang guys, kailangan nyo to i-convert. Kailangan pa nyo i-convert si 2 kilometers per hour into a value that is meters per second. So, kailangan nyo pa itong i-convert. And then you will actually have the same answer pa rin. Okay? Okay. So, let's have this another example. Example number 9. A 200 kilogram car traveling 200 meters per second coast to rest on a level ground in a distance of 100 meters. How large is the average friction force acting on the car? Okay, so for this one, we have this diagram. Mag-move yung car. Tapos bigla siyang tumigil. Ayan. Now, for this one, ang pwede mong gawin is ganito. First, alamin mo muna kung ano yung direction. Bakit siya tumigil? Bakit siya nag-zero? Kasi meron tayong friction. Diba, nag-move yung car natin. Tapos nagkaroon ng friction, kaya siya nag-zero. So, to do that, let's just compute for work. Now, work, remember the work energy theorem. It is the change of kinetic energy of this one, minus the kinetic energy of, mali ako, undo, hindi pala. The kinetic energy of this one, minus the kinetic, ayan, the final kinetic energy minus the initial kinetic energy. So, ito siya, at ito siya. Okay, let's try. The formula is 1/2 mv squared, 1/2 mv squared. What is the mass of the car? It's actually 2,000 kilograms. The velocity of the car at first, 20 meters per second. I-square natin yan. At i-minus natin sa 1/2. Mass ng car, 0, 0. Pero dahil sa friction, ang velocity na natin ay 0. So, ito lahat guys ay magzi-0 lang. Therefore, erase ko yung pinagsusulat ko. Therefore, the answer there is just this one. The initial. Baliktad yung kanina ko. Dapat initial guys ha. Final minus initial. Ito yung final. Ito yung initial. So, ito pala yung nag-0. Okay. The answer there is a negative 400 Newton. Okay. Example number 10. A truck of a mass 300 kilogram is to be loaded into a ship by a truck crane that exerts an upward force of 31 kilonewtons on the truck. This force, which is just strong enough to get the truck started upward, is applied at a distance of 2 meters. What is the work done by the crane? What is the upward speed of the truck after 2 meters? So, work done, remember? Sige, let's get the diagram. So, umakyat yung ating truck ng 2 meters. Okay? The initial velocity is this one. So, work done by the crane. Of course, force times the distance. Now, force applied times the distance. This is given. 31. Binigay naman yan sa atin. Times the distance. And we have that, the work done. The upward speed of the crane, yun nga lang, it has to do with the kinetic energy na. Please remember, work is equal to the kinetic energy final minus the kinetic energy initial. I'll erase my pen. It will be shown when I click the next one. So, therefore, okay, ayan. It has to do with this one. So, for this one, yan, upward pala na yan. So, for this one, we have this for our kinetic energy, 1/2 mv squared. This will just be 0. Bakit 0 yan? Kasi ang initial natin, VI natin, is just 0. Now, let's minus the upward speed, okay, the upward work and the work applied. So, pag minus mo yan, you will have this answer. So, therefore, if you have that, this one for this one, at pag minus mo yan, the change in work, so we have 3.2 kilo. So, I will put 3 zeros here. Let's erase the, yan. Hindi pala. Isang zero lang. Ayan. Kasi times, ayan. Ayan. I-divide mo ng 1,500. Tapos, that will be our V squared. Square root mo, and you will have an answer of 1.46 meters per second. Ayan. So, ayan. Wait lang guys ha. Okay, we have 64 slides to go. But for now, I think that should be our discussion muna, end of our discussion about kinetic energy. Later, I will send you a video naman for the potential energy, and that will be in this slide onwards. And the relation between the two, what we call the mechanical energy, the relationship between the potential and the mechanical. But for now, this is already good. So I hope you learned something, and then I'll see you next meeting. Bye guys.